Hey, hi there. You probably don't know it yet, but the sun is like death, or a jellyfish. I forbid you to look at it directly. Or from the side, at the only moment when you can really enjoy it when it's about to set. I hope you'll see thousands of sunsets. They can be orange, red, or purple. These unique colors, which pollution can intensify, depend on the particles present in the atmosphere and the clouds that reflect the sunlight, and also on smoke from fires or volcanic ash. You might find it colorful, bright, and magical. And it's a damn good excuse for romantic moments. I forbid you from starting forest fires just to have colorful skies. And since you already have stars in your eyes, I think it's the perfect opportunity to tell you about sunsets you'll never see, and about the colors our star can take on, as seen from worlds other than our own. Put on your glasses and let's start with Mercury, the planet closest to the Sun. On this celestial body, because there's no atmosphere, there's no scattering or absorption of colors. So from the surface, we would see our star as intensely white, just like from space. And since Mercury has an eccentric orbit, depending on the time of year, the Sun appears 2 to 3 times larger there than it does on our planet. And its brightness there is 5 to 10 times higher, which means that on a nice Sunday afternoon, it can reach 430 degrees. I forbid you from taking a walk there, even if you're accompanied. The icing on the burnt cake. Since Mercury orbits the Sun faster than it rotates on its own axis, and since its days are longer than its years, a phenomenon occurs there from time to time that can't be observed anywhere else, at least not on an empty stomach. A sun that sets, then rises again, and then sets once more. Let's escape this hell for another one, trying to observe our star from Venus. Seen from space, the Sun there appears nearly half again as large as it does to an observer orbiting the Earth. Except that once you're on the planet's surface, it can only be seen at best as a faintly yellow-orange spot. Here, light struggles to travel straight through an atmosphere so dense it could be cut with a knife. Our star is nothing more than a barely perceptible halo there, perpetually veiled behind a sky swept with clouds of sulfuric acid. I forbid you to go there, even well protected. Anyway, even if you could, you might get bored there. Because Venus rotates very slowly on its axis, from one sunset to the next, you would have to wait the equivalent of 243 Earth days. On the other hand, those, if they are visible at all, can last for weeks. And don't look in the wrong direction, because on Venus, which rotates counterclockwise, the Sun rises in the west and sets in the east. Let's go take a trip to Mars, the red planet. On this planet, 1.5 times farther from the Sun than Earth, sunsets are almost the opposite in color from ours. To put it simply, on Mars, which has a very thin atmosphere often filled with fine dust most of the time during the day, the sky takes on yellow-orange shades, sometimes pinkish or purplish. And when our star sets on the horizon there, it takes on increasingly dark bluish shades, sometimes even gradually turning to a pinkish hue. And thanks to the presence of fine dust particles in the upper atmosphere, which scatter the light, twilights here last much longer than on Earth. Even farther from our star, let's place ourselves near the gas giant Jupiter and its moon Io. Now, at an average distance of 778 million kilometers from the Sun, it appears to us about 5 times smaller than it does from Earth. The intensity of its light, paler than ours, is on average 27 times weaker. And if we could dive into the upper part of Jupiter's atmosphere, the Sun would probably appear dimmed by clouds and a brownish-blue haze, as depicted here by the artist Ron Miller. And now here we are near Saturn. Seen from this world, the Sun is now nearly 10 times smaller in size than it appears from Earth. The light passing through Saturn's rings must create stunning reflections and colors, producing sumptuous effects. And although the light received there is about 90 times weaker than on our planet, our Sun is still too bright to be looked at directly. Researchers believe that in Saturn's upper atmosphere, the refraction of sunlight on ice crystals must form parhelia, a splendid optical phenomenon that we can also sometimes observe on our own world. But let's move more than 1,400,000,000 kilometers farther away to reach Uranus, the planet that didn't choose its name. We are now 19 times farther from the Sun than the Earth is. And from here, 400 times less light reaches us. Standing on Ariel, one of Uranus's moons, the gas giant must always appear shrouded in pale blue. That must get boring over time. Like Neptune's deep blue skies, found 30 times farther from the Sun than Earth. At such a distance, the brightness received there is 900 times weaker than on our planet. And thanks to the talent of the artist Ron Miller, by landing on Triton, one of Neptune's moons, we can observe our tiny Sun, partially hidden by the geysers of dust and gas from Triton. And if we venture as far as Pluto and Charon, on average 40 times farther from the Sun than we are, the brightness received from our star becomes 1,600 times weaker than on Earth. Yet, even at such a distance, nearly 6 billion kilometers from the Sun, the light received by Pluto and Charon is still 250 times more intense than that of a full moon on our planet, bright enough to outshine all other objects in the sky during the day. Even here, at a staggering minus 230 degrees, our star is still difficult to look at directly. To sum up, relatively speaking, if from Earth our Sun appears this size, then here it is as seen from Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and finally Pluto. But let's come back down to Earth. For you, it would be hard to see more than one sunset a day, unless you do what the photographer Simon Roberts did and see 24 in a row in a single day. To do this, he flew around the North Pole at a particular time of year and at a precisely calculated latitude, allowing his plane to constantly chase and catch up with the sun as it fled over the horizon, thus witnessing 24 sunsets in 24 hours, which makes him the human who has seen the most sunsets in a single day. But if you want to see a lot of them in your life, you probably want to be an astronaut. Because on the International Space Station, which orbits the globe in 90 minutes, it's possible, if you stay awake, to witness 16 sunsets a day, which is still 27 less than the Little Prince, who would have seen his star set 43 times in a single day. Also, you can easily make them last longer without taking a walk in a book. For that, avoid the tropics, because our star disappears there along a path that's almost perpendicular to the horizon, so sunsets are shorter there. So go north in the summer or south in the winter, because our sun sets more slowly below the horizon there and night takes longer to fall. And if you enjoyed these sunsets, you can leave us a tip on Typee or Utip to support the baby.